And for geometric, formula is very similar. A couple of differences, though, to note. So we have G sub n, which is the 9th term in the sequence. G sub 1, first term in the sequence. R is the common ratio because we're using geometric. That correlates with the common ratio. N is still that term number. Notice now that this n minus 1 is in the exponent. Okay, it's not times n minus 1 in parentheses. It is in the exponent. So as you're writing these, make sure that you are writing it clearly in the exponent so that you don't confuse yourself. So for this first example, we again have a chart where this is our term number. First term, second term, third term, fourth term, fifth term. It is our input or our domain, term number, okay, independent variable. It's all that rolled up into one. G sub n is our term value. It is our range. It is our output. It is our dependent variable. So we plug in the term number. We plug in 1. We get out 2. We plug in 3. We get out 18. Okay, again, if you want to think of this as days and money, first day you made $2. Third day you made $18. All right, so let's jump to answering some of these questions. G1, G sub 1, first term is 2. R, common ratio. To get from one term to the next, what do we multiply by? So 2 to 6 to 18 to 54 to 162, we are multiplying by 3. Then we're going to use that and write our explicit formula. G sub n equals first term times 3, which is common ratio, to the power n minus 1. Notice I wrote that n minus 1 smaller and up top in relationship to that 3, so I don't get confused. Use the explicit formula to find the 7th term. So everywhere I see an n, I'm going to plug in 7. So G sub 7 equals 2 times 3 to the 7 minus 1 power. Now, I'm definitely not going to go 3 to the 6th power in my head. That's too much. So I'm going to type this into Desmos. This AB button up here, if you can see it being highlighted as I click on it, will get me to that exponent, and I will do 6. You can do 7 minus 1 if you want, but I know 7 minus 1 is 6, so I just skipped a step there. And our 7th term equals 1,458. So again, in the terms of my made-up context, 7th day, you made $1,458. Not a bad day's work. Now let's use that explicit formula to find the 21st term. So G sub n equals 2 times 3 to the 21 minus 1 power. Again, I'm going to use Desmos because that's a big number. Now notice I already have 2 times 3 to the power 6. I'm just going to erase that 6 and type in 21 minus 1 is 20. Now notice I have 6.9. Well, if I'm looking at my sequence, it looks like I'm going up. So why all of a sudden do I have a 6.9? I mean, 6.9 is right there in relationship to all the rest of my numbers. Notice that it says times 10 to the 9th power, meaning that I need to move the decimal over 9 spaces to the right. So we have 6.973568802 times 10 to the 9th power. So I need to move that decimal over 9 spots. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 6, 9, 7, 3, 5, 6, 8, 802. I can't even read that number. I'm going to throw some commas in there. Nope, too many. There we go. There we go. So we have hundreds, thousands, millions, billions. So 6,973,568,802. So on the 21st day, you're making $6 billion. Not too shabby. Question number 2. Let's see if it's as exciting as that last one. Consider this sequence. 2,048, 1,024, 512. All right, what's my first term? 2,048. Why, you are correct. Now, what do I multiply by to go down? Okay, my numbers are getting smaller. All right, so let's see. Let's go. First number divided by the second number. That gives me a decimal. I don't want a decimal. I want a fraction. With that fraction, 1/2. All right, well, it looks like it's being cut in half. Let's test that theory out in case you don't believe me. You think I'm faking it here. So 2048, we'll go times 1/2, and I get 1,024. Perfect. Let's do 1,024 times 1/2 again, and I get 512. Perfect. So I know that my common ratio is now 1/2. Use that information to make that explicit formula. G sub n equals first term times my common ratio to the power n minus 1. Let's find the fifth term. G sub 5 equals 2048 times 1/2 to the 5 minus 1 power. Definitely not going to do that in my head or even attempt to do that in my head. So I'll plug it into my calculator. To the power 5 minus 1 is 4. So it looks like the fifth term is 128. Okay, answer makes sense in the context of this sequence where my numbers are getting smaller. That makes sense. Okay, so I'm good. Find the 31st term. G sub 31. G sub 31 equals 2048 times 1/2 to the 31 minus 1 power. I already got that formula pretty much already typed in. I'm just going to erase that 4 for the exponent, plug in 30, and I get a really tiny number. Let's see, 1, 2, 3, 4, 5 zeros. 3, 4, 5, 1907. Okay. Now, I didn't tell you how to round, so I just tack on a couple decimal places there, and I'm good to go. So a very, very tiny number is what we have. All right, and the third and final example. This is so much fun, I know. During the first hour, there were 3 bacteria in a dish. Every hour after that, the bacteria doubles. Double means times 2 in case you didn't know. Okay, so we want to write the first 4 terms of the sequence. So first hour, there were 3 bacteria. Second hour, there were 6. Third hour, there were 12. Fourth hour, there's 24. Doubles each hour. First term was 3. Common ratio was 2 for doubling. So that means my explicit formula is G sub n equals 3 times 2 to the power n minus 1. Using that same explicit formula, how many bacteria will there be after the 13th hour? So we're going to go G sub 13 equals 3 times 2 to the 13 minus 1 power. And I will plug that back into Desmos. 3 times 2 to the power 12. So G sub 13 equals 12,288 bacteria. So I'm going to answer that in the context of the problem. Be 12,288 bacteria after 13 hours.